Hello students, in my previous lecture I discussed about the various components of man instrument system. I introduced you to the man instrument system. I told you why do we need man instrument system, and I discussed the various components of man instrument system. In this lecture I am going to discuss about the design factors of biomedical instrumentation system, or you can say man instrument system. That is, for designing a biomedical instrumentation system, there are certain factors that a biomedical engineer has to consider for designing that system. Or you can say, for a certain application, if you have to select a biomedical instrumentation system among the various other biomedical instrumentation systems, then also these design factors are there. These factors are there that need to be considered for selecting a particular biomedical instrumentation system for a particular application, which is suitable for a particular application. Now, what are the design factors? The design factors are range, sensitivity, linearity, hysteresis, frequency response, accuracy, stability, isolation, simplicity, and signal to noise ratio. So you might have come across all these terms in other subjects also, but here again I will be introducing you all these terms, or I will be telling in detail about all the factors here related to the biomedical instrumentation system. So I will be discussing all these terms related to the biomedical instrumentation system. So starting with the first design factor, that is range. So what is range? Basically, the range of an instrument. We know a biomedical instrumentation system is used for measuring a physiological parameter of a human body. Fine. Now, what is the range of that instrument? Range of that instrument will include all the amplitudes of that physiological parameter for which that biomedical instrument is expected to operate properly, or you can say the biomedical instrument will operate for a certain range of physiological parameter amplitude levels as well as frequency levels. Again I am repeating, what is range here? Range means all the physiological parameter amplitude levels, or you can say all the physiological parameter frequency levels for which the biomedical instrument system is expected to operate properly. And what should be the objective of a biomedical instrumentation system regarding the range? That biomedical instrumentation system should have a wide range. The desirable property is it should have a wide range, means it should be able to reliably measure the smallest amplitude of that physiological parameter to the largest value or the largest amplitude of that physiological parameter. So the range of a good biomedical instrument should be large. Now next design factor is sensitivity. So what is sensitivity? Sensitivity, it is of a biomedical instrument system, it is actually the ratio of change of output signal to the change of input signal, or in very clear terms if I have to say that the sensitivity of an instrument tells how small a variation of a physiological parameter can be reliably measured with that biomedical instrumentation system. So a biomedical instrument, how small change of a physiological parameter, how small variation of a physiological parameter can be reliably measured by a biomedical instrumentation system or biomedical instrument is the sensitivity of the biomedical instrument. Or in mathematical terms you can say it is the ratio of output signal to the ratio of change in output signal to the change in input signal. Again I am repeating, what is sensitivity? It is the ratio of change in output signal to the change in input signal. Now what does it mean the sensitivity of an instrument is high? It means for a small variation of input signal, that instrument is actually producing a large change in the output signal. For a small change, if I have to tell you in biomedical instrumentation system terms, then for a small change in the physiological parameters so measured, the output reading comes out to be large. The change in the output reading is large. So then we can say that the biomedical instrumentation system or the biomedical instrument is having a high sensitivity. So it also points to the resolution. The sensitivity also points to the resolution, which means resolution of an instrument is directly proportional to the sensitivity. What is resolution? Resolution is the minimum variation, or you can say the minimum amplitude variation of that physiological parameter that can be accurately read by the biomedical instrument. It is the value of the minimum amplitude variation of a physiological parameter. So this is resolution. Now for a good instrument, the sensitivity should be high. Moreover, for if you have found the calibration curve of a biomedical instrumentation system, what is calibration curve? Calibration curve is the curve between input and output. Here we have input and here we have output. The calibration curve so obtained, this is the curve so obtained is the calibration curve. It is the curve between the input and output of the biomedical instrumentation system or a normal generalized instrumentation system. So sensitivity, how you can represent sensitivity from the calibration curve? The sensitivity is the slope of the calibration curve. So if you have got a straight line like this, if you have got a straight calibration curve for a biomedical instrument, then the sensitivity is the slope of this calibration curve. Now if the calibration, it doesn't mean that the calibration curve for an instrument will always come out to be a straight line. It can be linear as well as it can be non-linear. Here the curve is linear. I have shown here the linear curve. So if the calibration curve is linear, which it means that the sensitivity at all the points will be constant. That is, for the entire range of the physiological parameter to be measured by the biomedical instrumentation system, for that entire range of that physiological parameter, the biomedical instrumentation system is going to have the constant sensitivity. That is, it will show same change of output signal to the same change of input signal. But if the calibration curve is non-linear, then the sensitivity is not constant and it is a function of input signal. So here I have used the term sensitivity, which is the ratio of output to the input. In electronic system measurements, the term gain is used instead of sensitivity, and whereas in mechanical instruments you will get to see the term amplification instead of sensitivity. Now next design factor that I am going to discuss is linearity. So how you will decide a instrumentation system is linear or not? Whenever a biomedical instrumentation system is following homogeneity as well as superposition principle, then we can say that the biomedical instrumentation system will have is highly linear, will have linearity. So an instrument is said to be linear if the instrument comes out to be linear. That is, if the instrument is following the superposition and homogeneity principle, and if it comes out to be linear, then it is going to have a constant sensitivity for the entire range of measurements, as I've already told you just now, that the sensitivity will be constant for the entire range of input, and the working range, for a good instrument to be linear, for a good instrument, what in terms of linearity, if I have to say, then a good biomedical instrument will have linearity over the entire range of the physiological parameter amplitude or frequency. And if it is not possible, it is better to have linearity at least in the important sub-range of the input physiological parameters measurement. Now, in some instruments, a certain form of non-linearity is purposely introduced to create a desired effect, whereas in others it is desirable to have linear scales as much as possible over the entire range of measurements. Now, the next design factor that I am going to discuss is hysteresis. So, what is hysteresis? Hysteresis, it is basically the variation in the output of a biomedical instrumentation system. I am continuously here in this lecture I am using the term biomedical instrumentation system because I am discussing all these design factors with respect to the biomedical instrumentation system. Okay. So, what is hysteresis? It is the variation in the output reading of the biomedical instrumentation system or biomedical instrument for the same value of input. That is, for same value of input you are getting two different readings at the output of the biomedical instrumentation system. And how? And it occurs during loading or unloading, or you can say at the time of ascending or descending direction. So, ascending means when you are actually increasing the value of input, and descending means when you are decreasing the value of the input physiological parameters. So, at the time of ascending and descending, at the time of ascending and descending for a certain value of input, if you are getting two different outputs, then we can say that the instrument is having hysteresis. So, I have also used the term loading and unloading. So, here loading, by loading I mean to say that the instrument input is increasing in amplitude, and by unloading means the input physiological parameter amplitude is decreasing. So, let me give you an example of hysteresis. Suppose if you are using a spring as in a spring balance, and for measuring the force, we may get different elongations for the same force, and this error has occurred because of the hysteresis. Or you can say the mechanical friction in a meter can cause the movement of the indicating needle to lag behind corresponding changes in the measured variable, thereby resulting in the hysteresis error in the output reading. So, this was all about design factors. There are various other factors also remaining. I will be discussing those factors in my next lecture. I am ending this class here. Thank you.